Hi, good afternoon everyone. Thank you for joining us today. My name is Ben Cripps, and to my left I have my colleague Martin Pinner, and we're from Application Performance. Today we're here to tell you about how you can use continuous integration tools such as Jenkins to help ensure you've got a quality build with less exceptions and a performing build as well at the same time. So today we live in a very technical, demanding world. Technology is all around us, hence why we're here today as well. And we all demand fast, reliable solutions. As part of this, though, we also need to keep up with the competition, which means we need to be fast, iterative, and keep introducing new improvements to our solutions. And it makes our challenge even harder, is that we've got market leaders such as Facebook and Amazon and so on, leading the way and setting customers' expectations. So how can we do this? Well, we could use a development pipeline and continuous integration using a tool such as Jenkins, where we can build our solution, run our unit tests, and then add additional gates into the pipeline to ensure we've got code quality and performance verification in process as well. So the first step we're going to show you today in this quick and fast demo is the code verification stage. And I'm going to hand you over to my colleague Martin.
Hi everybody, so I'm going to introduce Overops, which is a code quality gate. Basically it does a dynamic analysis of your code while you're running your unit tests, so that even if your unit tests pass, it can detect exceptions and errors within your code, and depending on whether you exceed some sort of threshold based on either the volume of exceptions or the type of exceptions, then it can mark the build as unstable. And better still, the level of detail that you get with Overops in terms of the context information, the source code, the variable values. It's like having your own production level debugger available throughout the life cycle. And this means that it makes it much simpler. In fact, you can avoid trying to reproduce a problem, and you can massively reduce the time to fix. So without further ado, so this is what we're trying to avoid, where you have a production problem and you send it back to development and you can't reproduce it. Okay, next. So let's have a look at the actual code analysis tool now in action. So I've written this little application, this little class called month. I'm very proud of it. I know, who needs another date time class, but bear with me. And I've got a test 1 there, which is going to do what I call an identity check. It's going to convert the integer value of a month to the string, so it'll convert 1 to January. It'll then convert it back from January to 1, and hopefully we end up with a number we first thought of. And we're going to just repeat that for months 1 to 12. So if we go next, I've got a very build and trivial build script. Fourth line there compiles my JUnit test, and the 6th line there runs my JUnit test. And the only things that are extra things that we've added to the command line is the Overops agent, the agent lib to keep the agent parameter, which is going to actually do the detection of the exceptions and errors. And I've also passed in a couple of variables, $1 and $2, which I'm going to tag this execution with the job name and the build number. And so here I've created in Jenkins a little project called Overops example. And if we click in it, and hopefully the Wi-Fi holds up for long enough for us to actually do this for real.
It is thinking.
It's thinking, is it?
Yes.
Thinking hard, thinking a lot. You wouldn't think it would be so difficult to click on a link. It's a bit sad.
It's not well. So I go back to the...
This is demo gremlins. They've hit us already, haven't they? Didn't take long.
Just be a second. Sorry about this, folks.
Oh, great. Cool. So if we just go into the configuration screen, we can see what we've set up. At least I hope we can press the button. Fingers crossed, everybody. Cool. And we have our build command. As I say, it's very simple shell script, but we're passing in the job name and the build number as parameters, and you'll see those being tagged later. And then we've set up a post-build step, which is the overops quality gate. Again, we've identified it by the job name and the build number parameters. I've got a tick box there, fifth one down, mark build as unstable, so it will actually reject this build if it finds some errors. And then I've got some quality gate options, and there's about half a dozen you could use. The two I'm going to use for this demo today is the total volume of exceptions. So if I have more than 10 exceptions, then I fail the build. I mean, I'm being quite kind to myself. So if I've got fewer than 10, I'll get away with it. And then I've also got one called a critical exception gate, which is if any of those that I've listed there, null pointer exception, array index bounds, out of bounds exception, etc., if any of those are caught or thrown by the application, then that's game over, immediate fail. So let's now go back and run it. So we can do build now. If you go on to that's it. And rather than wait for it to complete, let's just look at the previous one. And if we look at the console output, we can see that it ran build.sh and passed in overops example and 15, which is the build number. It ran the JUnit test, and the JUnit test passed. Brilliant, job done. We can ship this code. Can we? And go and play table tennis. Well, except that it says just after that, overops quality report changed the build result to unstable. So let's have a look at why it's done that. So if we look at the build quality report, which is an extra button that you get added to your build, then we can see that overops has marked build 15 as unstable because the below quality gates were not met. In fact, there were two quality gates I defined, if you remember. One was the total volume, which actually we've passed on. It's in green because we only had the one exception thrown, and I gave myself an allowance of 10. But the next one, it did fail on because I have an array index out of bounds exception being thrown during the test. So even though I passed the unit test, there's something fishy going on here. So if you then click on that link, and here's one we did earlier just to make sure it will actually get through. Then the important part of the screen really is the fact that we've got the code that you can see. We've got the line where the exception was thrown, shown by the orange flame there. We can hover our mouse over month, and we can see it's an array of 12 items, the actual months of the year, January to December. And if we hover over the variable n, we'll see that it's actually 12. So pretty clear what's going on here. We've got a sort of n-1 type problem, and that's thrown, we've gone one past the end of the array, so it's thrown an exception, and 2 lines down you can see where it's caught, and we're doing nothing with it. We're throwing that result away. And in fact, we're just going to return null if we hover over the result. We can see over time at the top there how it's behaved over time. So these are individual test runs that we've run, and each time we've failed with an exception. And on the top left, there we've got some context information. We can see it's an array out of bounds exception. It's been swallowed. It came from a particular server and on a particular application, and it's our build number. Yes, good. So if you go next. So just to summarize, we've used overops as a code quality verification step. We've prevented dodgy-looking code making it out to production, because who would want a null pointer exception or an array index out of bounds exception leaking out to production? That sounds like an accident waiting to happen. And so we can reject it and send it back to the developers and hopefully make a better job of it next time. And next time, we will hopefully get through to the next stage, which is the performance verification. And for that, I'm going to hand you back to Ben, who's going to describe that.
Thank you. Cheers, Martin. So, yes, coming from a company called Application Performance, we also see performance as a critical issue as well. So we see those as bugs. So what can we do to actually tackle those particular issues? Or what does it actually cause? So if you've got a slow website, and you might know some of these already, hopefully you do, you're going to have reduced conversion rates. So that might be reduction in products being bought, registrations and sign-ups and so on. You're going to see higher bounce rates as well, which means your customers, your visitors are actually going off to your nearest and dearest competitors. So this stuff matters. And then as well, on top of that, you're going to have reduced page views per session. These all impact you, and not just you as a developer or development team, but also the business. IT and fast-performing websites are today a business concern, and performance can't be ignored. So we're going to do a quick demo, another quick one that we've done, Blue Peter style, showing how you can put in a performance gate into a tool such as Jenkins. And for this, we're going to use Rigor. Now, Rigor can detect performance issues, but it goes one step further, and it can also provide you some advice on how to actually resolve these issues. So rather than you having to spend time trying to work out why you've got a CSS render blocking event, Rigor will help you find it and track it down and resolve it. And you can put this into your Jenkins pipeline so that you can actually tackle it before you release anything up to your production environment. That, in turn, will protect your production environment, your end users, but also make you as a team more performance aware, which is all a good benefit for everyone. So let's do another demo, part 2.
That one?
Just for a second.
No.
No.
Which one is it?
It's
Oh, it's that one.
no. That one. And then the next tab, please.
So I can't see it.
So a couple of technical issues. Sorry about that.
I can't get to
Do you want a hand, Martin? Excellent. So if you just go into the next tab for you, please.
Yeah, but I can't see it.
Yep.
You won't go to the next tab. Do you want to
Control
drive?
5.
Sorry?
Control 5. Excellent,
Ah,
cool. So just like Martin, we've got a predefined project here in Jenkins called Rigor. And if we click on the configure option, you'll see that we've got a plugin very similar to the OverOps one itself. Just got a few issues here. Sorry about this, folks.
Can you get it back onto
Yeah.
the browser?
No worries. So if I click on configure here, hope the internet works again, which it does. We do have some luck. And if I scroll down slightly, when it catches up. It's still catching up. Oh, dear. Where's it gone? Sorry about this. But what we can see, or what you would see here, is actually my internet's gone, is a list of settings that you can actually define within Jenkins itself using the Rigor plugin. So you can define how many performance rules you can break within the actual build itself. And you can also target particular rules to say, if your website breaks this particular rule, reject the build. So you can force the performance issues back to the development group to be resolved before you push it up into your UAT or production environment. And once you get that, if your build does get failed by Rigor, you get a general report showing you where your issues are. And then within each of these rules, you can actually click, and it will take you straight to a page similar to this one here. So this one is a particular rule around resource without caching information, which is a real common issue that we see on a lot of customer sites. It's quite a basic one. But you can see how Rigor here gives you some guidance in terms of how severe this particular issue is. Now, in this particular case, we've only got one affected URL, but like I said, on customers, we tend to see it on, say, 80+ resource requests getting made on the page. So it is a high severity. But the actual ease of fix, according to Rigor, is easy, which is great. And what Rigor will do, you can actually click on these additional sections here, such as defect details and how to resolve. Rigor will give you a plain explanation of what that issue is. And it will give you some diagrams to explain it as well, if it can help explain it. But then it will also tell you how to resolve those particular issues. So in this particular one, it will tell you how to do it for IIS, Apache, and so on. So rather than you having to go away, Google, spend time to try and find out how to resolve a particular issue, it's all there for you in Rigor. And on top of that, you can then drill into the individual assets, and it'll show you more potential issues with those particular rules as well. Yep.
This one?
Yep, cool.
So let's go down.
So you can see here, if you did fail your performance verification step, it's going to stop your slow code from progressing up to production and push it back to the development team. And if everything passes, you're good to go for deploy. And all this combined will give you the confidence in your build in terms of code quality and performance is ready for the real world out there, which is great. So sorry about the technical issues on the slides. Not had that before, unfortunately. But we're going to do a very quick Q&A back at our stand at B2, which is at the corner, just down over there. So please do feel free to come down and ask us any questions. And hopefully we'll give you a slicker demo as well.
Yeah, if you want to see the demo working.
Cheers.
Thank you.